Factor analysis is a statistical method used to identify underlying factors or latent variables that may explain the observed relationships among a set of observed variables. It is a dimensionality reduction technique that aims to simplify the complexity of a dataset by capturing the common variation shared by the observed variables. The main idea behind factor analysis is that observed variables may be influenced by unobserved, latent factors. These factors are not directly measured but are inferred from the patterns of relationships observed in the data. By identifying these latent factors, factor analysis provides a way to explain the underlying structure that generates the observed correlations among variables. Here's a basic outline of the factor analysis process. The first step in factor analysis is data collection. In this step, you will gather data on a set of variables for a sample of individuals or entities. These variables should be potentially related to the underlying factors of interest. Next, compute the correlation or covariance matrix based on the collected data. In this step, you will compute the correlation matrix if variables are on different scales, or the covariance matrix if variables are on the same scale based on the collected data. The next step is factor extraction. In this step, you will apply a mathematical technique, example, principal component analysis or maximum likelihood, to extract the underlying factors from the correlation/covariance matrix. The goal is to find a small number of factors that can explain most of the common variance in the observed variables. Next is factor rotation. The extracted factors may not be unique, and their interpretation might be challenging. Factor rotation is used to obtain a more interpretable and meaningful solution. Orthogonal rotation methods, example, bar-Imax, aim to produce uncorrelated factors, while oblique rotation methods allow for correlations between factors. The final step is interpretation. In this step, you will interpret the extracted and rotated factors based on the observed variables that load heavily on each factor. Factors with high loadings on specific variables indicate a strong relationship between the factor and those variables. Factor analysis is commonly used in various fields, including economics, psychology, sociology, and marketing research. In economics, it can be applied to understand the underlying structure of economic indicators, identify macroeconomic factors, or study consumer behavior patterns, among other applications.
Hello, thanks for joining us in this study of factor analysis and its potential benefits in data science. We hope you found it informative and useful. If you enjoyed this video and want to see more content like this, be sure to hit the like button below and leave us a comment with your thoughts or any questions you might have. Your feedback is invaluable in helping us create content that best serves you. Also, you can become a Patreon supporter today. Until our next video, keep learning and stay curious. Thanks for watching.